Hey, before we get started, last week we talked about pressure. Told a little story about my 8th grade science teacher who happened to be a drug addict. Can I tell you guys that? Yeah. Okay, so I would like you to look out the window and in her honor, decide if it's high pressure or low pressure. And if you don't know off the top of your head, no one say anything out loud. If you don't know, flip back to the pages where we did the compare and contrast on pressure, which happens to be page 31. So flip back and take a look. By looking out the window, decide if you think it is high pressure or low pressure. Don't say anything out loud. Of course it's low. So I want everybody to figure this out. We are looking out the window and you are checking page 31. If you don't remember, we are trying to decide if it is high pressure or low pressure outside right now. And I'm trying to find the exact pressure. You sure can.
Thank you.
It's hot in here. You look like you just, oh, it's hot. Yes, it's a whopping 34 degrees, Michael. It's hot. See me.
No, it's way hotter than 30. It is warmer than 34 degrees.
Oh, yeah. What's going on here? It definitely is. It says it's 47 on my phone. What's going on here? It's supposed to be a high 60. I'm thinking my weather station isn't quite working. But anyway.
My whole life's been a lie.
Anyway, what are you thinking right this very second? We look out the window. And my 8th grade science teacher, you know, the drug addict, who was high all the time. She really was, Mrs. Burns.
I believe you.
She really, really was.
It must be the science that did it.
She was my earth science teacher. I know.
Oh,
She had a drug problem.
oh, I'm so sorry.
It's okay.
Well, is she still teaching?
Well, no, because she OD'd.
Oh.
Oh.
Whoa, I didn't expect
I know, I didn't actually share that part with my students, but I guess they just heard.
that. So, yeah.
That's the only reason I knew it turned out she was a drug addict. Sorry, maybe that was too much information, but anyway, she was high, and I say this, and I know I'm joking, and I shouldn't joke about this, but she did stand out in my head, and she told me, do you guys remember what she told me to say? High, dry, cool, and clear. So let's look out the window. Is it dry, cool, and clear? Now, Michael disagrees with the whole cool situation, and we'll come to that. But is it dry and clear outside right now? It is 100%. Well, yeah, okay, I shouldn't use the word 100%. Is it pretty much clear? Yes, there are some clouds in the sky, but if you had to say clear or cloudy, your gut would probably go, especially if those of you who are looking off in the distance, you might see some more clouds. For those of you who are looking right here, it is pretty much cloud free. So it is clear and it is dry outside. Now going along with Michael, Michael says it is not cool out there. Right, and it could be cool, it could be warmer if it was a low pressure. So I know that part is a little deceiving. So if we go with a dry and clear, you know that it's high pressure. High pressure is typically a nice day out. And while it's not beach weather yet, it's still a nice day for a day in March right now. So I've neglected that over the past week or so. I keep meaning to quiz you on that. I quizzed Mrs. Jones the other day in the parking lot just because she was there and she said it was nice out. So I asked her. And by the way, I just looked up the pressure and now I forgot. I think it was 30.
30.15.
Okay, and mine's at 30.25, the one I was looking at. So either way, that's about right here. So Mr. D's was there, mine was there, depending on where it was. So we're here. We'll typically go with this 1 atmosphere is like average. Anything above that's going to be high. Anywhere below that's going to be low. So we are looking at a fairly high pressure, but not as high as it possibly could be. On the weather station that I looked up, and I'm not sure what's going on with this one. This one is definitely wrong. It did have a little arrow next to the pressure symbol, which means it's still going up. It's still going to continue to be a nice day today. So that is something that you need to remember. So I knew I threw that out there, but it is something you have to remember. High, dry, cool, and clear. Speaking of, I had you yesterday demonstrate high pressure on your desk. Can we do that again, please? Everyone get your hands ready. Everybody, I'm not doing this till I'm not moving on till everybody does it. Take your hands and put high pressure on your desk. What kind of air is going to be putting this high pressure on the desk? No, I am not okay because you guys are taking too long to remember this stuff. Stressing me out. So what kind of air pushes down on the desk? Right, cool or cold air pushes down on the desk. Again, do you remember why?
More dense.
Because it's more dense. Cold air is more dense because cold air cuddles. So the cold air is pushing down. Warm air, just like when you put less pressure on your desk, you kind of pick your hands up. Warm air rises, so it's not pushing down as much. So it's lower pressure. That is something you're definitely going to need to remember for today. So like I said, I need you on page 27. Quick review, because I feel like I might have rushed through a little bit of the wind. So we're going to go over it again. Lost wind. Give me a second. There it is. Okay. So we talked about that there's uneven heating across the world, across the earth. Places like us are rather cold, but not, oh, wait, hang on, there's a line. Jake's next. Go ahead, Jake. There's uneven heating around the world. We're kind of cold. Florida's pretty warm. Canada's even colder than us. So wind's job is to share the wealth. Spread the cold to the warm people, spread the warm to the cold people. It's trying to even us out. Yeah, it's not working in here, is it, Riley? No. It is cold depending on where you're sitting. It definitely is. Or what you just did last period, apparently. It's a little cold over there. You didn't come from gym class? No, sorry. Oh, you were just outside. What were you doing outside that you got that? Oh, but your cheeks are rosy because it was. Oh, okay.
You're still sweating?
He's not sweating. His cheeks, but are your cheeks rosy because it were as a little chilly outside though, or it's because you're warm? Oh, okay. All right. Anyway, sorry, not to talk. Any other personal information you want to share with us? No. Sorry. All right. Different temperatures cause different pressures. This is what I just said. And I cannot remember, did we add a little note over here to this? If we didn't, I'd like to now. So somewhere off in the margin, I'd like to talk about what we just demonstrated. Cold air. What kind of pressure does cold air have? High pressure. Why? Because cold air sinks because it's more dense. You got it. So a little note off to the side where it says different temperatures, different pressure. Cold air, high pressure. Warm air, low pressure. Whoa, I almost just died on a globe over here. And then the next part is to remember, just like farts, wind will always blow from high pressure to low pressure. Then also, just like farts, when that pressure builds up in your butt so that it is really high in your butt and really low in the regular air, what kind of fart do you have? A very strong fart. So just like when there's a big pressure difference, there is a very high pressure difference. There will be a very strong wind. A student 1011 had another great way of remembering this, and it's never occurred to me. Maybe Mr. D, it's occurred to you. here we have an incline. If I put something on this incline, which way will it go? Going from the high side to the low side, right? Right? Things go from high to low. Have you taught that before? It blew my mind.
I'm with, incline.
Blew my mind. Came right to him. He's like, why don't we talk about this? I'm like, oh, because that's really a great idea. Wind always blows from high to low. Things always roll from high to low. Then even better, he wanted to change the pressure difference. So make one side really, really high. And make the other side really, really low. If you were to sled down this compared to the other one, how are you gonna sled? What's it gonna be like? Faster. Okay. So I don't know if you can even see it, but that marker rolled down faster. I told this student he should be an earth science teacher. He laughed at me. Not sure why, but anyway. So things always roll from high to low. Sledding goes from the high end of the hill to the low end of the hill. And the greater the difference, meaning the steeper you are, the faster you'll go. The steeper the bigger the difference, the faster the wind.
You're telling me,
So I am telling you.
if I go up where there's no pressure, right? Like I'm talking like 10,000 feet,
Okay.
and I unleash the most ungodly.
I don't know. So,
exhausting part of high pressure. The stomach ache instantly relieved. Just the giant part. It'll be bigger.
I have no idea because I just use it as an analogy. I'm not using it as actual science. I do not know the actual pressure in your butt when you have to fart. I just know how my butt feels. So I just know how my butt feels when I have to fart. I feel pressure. I don't know if there's actually a pressure difference, but to me, it feels like there is. So I'm not that kind of science. I don't understand the human body, but let's keep going. So that student who did the whole steep hill thing also made a discovery here when we talked about isobars. Did we get that bullet for you guys? The isobars? And I showed you this map, which has isobars, lines that connect areas of equal pressure. Well, that student then related it to what we did in chapter 2. Chapter 2, when these were elevations, do you remember what it meant when the lines were close together in chapter 2? It was a steep hill. Steep hill. Now, when we turn this into wind, what does it mean when the pressure lines are close together? It means a steep gradient for pressure, but it also means the winds are going to blow really fast. I think I owe some of my paycheck to this kid in 10-11 because he made some connections for me. Okay, hopefully it helps you guys a little bit too. Did we then get this last bullet that I have in large letters? Wind is named for the direction it blows from. So it looks like we did not. Please add that. So the weather person might say we have a southerly breeze or a northerly breeze. And that means it's blowing from the north or from the south. So northerly means from the north, southerly means from the south. This is good. This is helpful. Because if we know we have a northerly breeze coming from the north, where's it coming from? And what's north of us? Canada. And what's the weather like in Canada? Colder than us. So we have a northerly breeze. We know it's bringing colder air to us. So again, I don't just say cold because even in the summer, if we have a breeze coming from the north, it's going to be colder, but not like snowman weather, but it'll be colder than if it came from the south. This is also helpful. Let's take a look at this map over here. It's just a map of New York State. We live about here. Well, you guys, we live more down here, but general gist, you live about here on the edge of Lake Erie. Now, typically we have what's called a westerly breeze. which means, again, what does a westerly breeze mean?
Comes from the west.
Comes from the west, because winds are named from where they come from. So that tells us if we live here, the wind is coming this way from the west. What kind of weather will it bring? Well, because it's hot over here. Not necessarily hot or cold. If it's coming across Lake Erie, what is it? Somebody said it. What'd you say? It's wet. So wind that comes over Lake Erie is going to be wet because it's going to soak up all the water from Lake Erie and dump it on us. So knowing where the wind comes from is helpful because it tells you what kind of weather to expect. All right. So that's it. Did we talk? We labeled these guys yesterday. That's where we started, wasn't it? In this class. My other class, we forgot to label these. So if you don't have them labeled, I already labeled them with the name, but you also are responsible for knowing what they do. So you need to know their name and what they do. An anemometer measures wind speed. So the wind gets stuck in those cups and that spins around, and then something or someone counts how many times they spin per minute and then change that to miles per hour or knots. And then a wind vane tells us wind direction. So if you, again, you don't have those labeled, anemometer is wind speed, wind vane is wind direction. You do need to know the name and what they do. Then we're going to move on to the two types of breezes that you might have if you live on the coast. So this one I do have labeled Lake Erie. So even though it's a lake, I guess I called it a sea breeze. But again, maybe I should have called it a lake breeze. Either way, it's officially called a sea breeze. So since it's called a sea breeze, where is the wind coming from? The sea, because remember, they're named from where they come from. So, or in this case, the lake, but either way, it's coming from the water. Now, I'd like you to take a look. I can't put them both up here at the same time, but take a look at those two pictures. Let's play Spot the Difference. You know that game where you look to see what the difference is between the two of them?
There's a sign.
There's a sun and a moon. Yes, there are a couple other differences just because of the way I copied and pasted. Half the house is missing. The clouds are missing there. That's not the important part. No, it's really not. The important part is the sun, which hopefully you guys know I'm implying it's day. And then the moon. But in case you don't make that connection, you can go right ahead and label them. You don't have to if you got that moon is night. Did anybody see the moon this morning? It's gorgeous. It was just setting super. I don't know if it was a full today or full tomorrow, but it was just setting on the way to work today, and it was huge and pretty, and it was really nice. You might not be able to see it if you had too much fog, but I didn't have fog where I was. Anyway, sorry, off topic. So we have two different types of breezes depending on if it's day or night near a large body of water. Now, when I say a large body of water, Lake Erie, Lake Ontario, they count. Rushford, Lime Lake, they don't count. Okay? A pond in your backyard, that doesn't count either. So we're talking a big lake. Some of the Finger Lakes might get a little bit of this. They might be big enough, but not as small as Lime Lake, not a pond in your backyard. We're talking a big, large body of water. So we need to talk about cold air and warm air and how that changes the pressure depending on if it's day or night. And before we do this, I need you to take a mental field trip. Normally I teach this in a different order so you understand this concept. But right now I would like you to take a mental field trip to a pool in August. And since it's a mental field trip, let's make it the prettiest pool you ever did see. Okay? If you can't imagine the prettiest pool you ever did see, a regular old above ground pool with a cement pad or blacktop pad works too, okay?
School pool.
No, it has to be outdoors. Sorry, it does have to be outdoors. Sorry about that. So it does. So town pool.
We're going Lake George.
Does the town pool have like cement around the outside of it? Okay, so that works too. But I mean, since it's a mental field trip, let's go somewhere prettier. But whatever works. Whatever works for you, but like Anthony said, it does need to be an outdoor pool. So we're gonna picture daytime. Oh, and by the way, it's not a heated pool, so sorry. I know, sorry, I just ruined some of it.
So it's not Yogi Bear.
Okay, I'm sorry, I just ruined some of this. So you go late in morning, early-ish afternoon. What has heat? The sun is shining, the sun is beating down on the pool. What's heating up faster? The pool deck or the water? Stop and think, don't shout it out. Don't imagine yourself at this pool. What's feeling hotter to the touch because it's heating up from the sun more?
I know.
Okay, do you guys mind if I call on Anthony? Anthony, what? Oh, Justin does. Anthony, what's heating up faster? The pool deck.
You wanna know why?
Maybe. I mean, I know why,
I do too.
but let's see if
It's
you know.
because the pool water is not heating up as fast because it's reflecting the light and it's reflecting the heat and it's evaporating. So the stuff that is getting heated up is going.
I mean, you have some valid points in there.
And then the pool deck is also probably like lighter color, so it's, you know.
You have some legit valid points. You do have some valid points. You are missing one concept, and you want to know why you're missing that concept? Because no one's ever taught you the one concept. Because I normally teach it the week before I teach this, but I went in a different order. I'm going to bring it up. So as Anthony says, so it works the same way with a pool as a lake and land as it does with a pool and a pool deck. So just like Anthony said, during the day, and we can write, I'm going to have you take notes just like I am right here. During the day, land heats up faster. So as you can see, I need to just give some room. So guys, make sure you give yourself room to take notes underneath. It's on page 27. And the water heats up slower. If you cannot picture this, I have another way of picturing this, but hang on, Anthony, we don't have time right now. But I have a disclaimer on this type of a mental field trip. This one definitely has to say a mental field trip. Do not attempt this at home. But imagine making a big pot of macaroni and cheese. So you take a big pot, you fill it with water, right? Because you got to cook the noodles. Now here's the part you can't do at home, but picture it anyway. Put one hand in the water. Put your other hand on the metal pan. Which one heats up faster? The pan heats up faster. Metal, ground, cement, land, all heat up faster than water. And the reason for this is because water has a higher, I'm going to go specific heat. And now that is a phrase you've probably never heard, specific heat. It's not quite. I'm going to add over here that the land heats up faster because land has a lower specific heat.
I have another thing.
Okay, what? Is it relevant?
Yes.
Okay, what?
So also another reason land heats up faster. Because one, the water moves. So the water that's on top could also be the water that goes right to the bottom. Also, the molecules and the atoms, they're more together on the land, so that it's easier for the sun to heat them all up.
No.
Yeah.
No. All right, we got to keep going though, but we will come back to a lot of the stuff Anthony said. Grab your reference table. Grab your reference table, open it up to the front cover, please. This is not when I usually teach it. Well, why the heck not? We'll throw it in here because we need to kind of understand the concept. Upper right-hand corner is a whole chart that spells out some specific heat. So specific heat is, and there's some room on your reference table. So specific heat is heat. How much energy is required to heat something up? Because how much energy is required to heat something up? That's the specific heat. Specifically, it's how much heat is required to heat something up. One gram of something, 1 degree Celsius, but that's a little much. So specific heat just means how much energy is required to heat it up. And then it lists them in order, and it has it in units. The units are officially joules per gram per centimeter or Celsius. Again, it just means how much energy, that's joules, is required to heat 1 gram of something 1 degree Celsius. You don't need to know the details there. Specific heat is just how much energy you have to put in something to heat it up. As you demonstrated with the whole macaroni and cheese thing, metal heats up faster than water. So if it heats up faster, does it need more or less energy to heat it up? Yeah. So it needs to be on the stove less amount of time to heat it up. Notice lead, copper, iron, those are all types of metal. They're at the bottom of the list. They have a low specific heat. Water, there's 3 types, liquid, solid, and water vapor. They're at the top of the chart. They require more energy to heat them up. And then we've got 2 different kinds of rocks in the middle. We're not going to really do anything with this right now. I just wanted to point it out that it was here. Just as how water requires more energy to heat it up than, let's say, rocks. All right, back to page 27. We'll come back to that in about 2 weeks. So back to this, you already have these 2 bullets filled in. Land heats up faster. Land heats up faster. Water heats up slower. So because the water heats up slower and the land heats up faster, if I put a thermometer right here on each of them, right above the land and right above the water, which one's going to be colder? Water. Water heats up slower, right? So if I measure the temperature of it coming off of the water, it's going to be colder. So over on this side, colder. This side, warmer, because the land heats up fast. All right, now we're getting into that stuff we have to remember. Since it's colder on the water, what's the air doing? What's cold air do? Cold air sinks. Cool air sinks. And then what type of pressure does that sinking air push? Remember when it's sinking, it's pushing down. And you have high pressure. Now let's go over to the other side. Since we have warm air, what's that air doing? Warm air rises because it's warm air rising. What kind of pressure do we have? Low, or at least low pressure. So if I was to draw this over, I'd have a big H over the water and a big L over the land. And which way does wind always blow? And no. Farts. Thank you. Wind always blows from high to low. Label that arrow wind. Guys, everything on this chart, you have to be able to recreate. Notice I didn't say you have to memorize it. What do you need to memorize? Water heats up slow. When something's cold, the air is sinking and high pressure, and wind always blows from high to low. So you need to be able to make this picture. During the day, if you go to the beach, can you picture yourself at the beach? Looking out at the water? Do you feel a breeze? Do you? You should. When you're at the beach, can anybody picture which way their hair is blowing when they're looking at the water? Or figure it out from this picture? Hair should be blowing back because the breeze should be coming from the water to the land. And Jake's got it. Okay. Those long locks blowing in the breeze during the day. Let's recreate it now at night. Some things are going to change at night. Now, on our mental field trip, I need you to be in that same pool you were just at. You're going for a night swim. We're talking 10, 11 at night. My kids love this. Don't get to do it often. We don't have a pool. We go to a friend's house, we go on vacation. Their favorite part is swimming at night. What's so nice about swimming at night? What about the temperatures at night? How's the pool feel? Pool feels nice and warm. How's that deck? Or if we're at the beach, how does the sand feel?
Cool.
Feels cool. So just like water heats up slow, what else do you think water does? Or what else can you say water does? Cools down slow. So now we're at night. We're gonna go through the same deal. Give yourself more room if you needed it. Water cools down slower. Why do you think water cools down slower? For this, be scientific here. Because it takes longer to heat up, it also takes longer to cool down. And the reason is because water has a higher specific heat. Now, since water cools down slower, what's the temperature going to be over the water? The water feels nice and warm. So it's warmer here. And because it's warmer on the water side, which way is the air moving? Wait, warm air rises. And because the air is rising, what's the pressure? Lower. So again, not something you don't have to memorize all of this. You just need to be able to walk yourself through it. If something is warmer, the air is rising, which just picture your hands rising. There's less pressure on the desk then. Now let's do the other side. How did that land or the sand or the pool deck feel underneath your feet at night? Land cools down faster. And officially it does this because land has a lower specific heat. And because it's cooling down faster, the air above the land will be cooler. And what does cold air do? Cold air sinks. So what kind of pressure? We have sinking air, high. And again, if we were to draw this, we now have an L over Lake Erie, an H over the land. So at night, the breeze should be blowing from the land to the water. It reverses. And again, if you were to go to the beach at night, you may notice that if you're looking at the water, your hair is now getting all in your face because the breeze is coming from the land towards the water. these different breezes are also the reason they put so many windmills along the coastal areas. Because there is always going to be a breeze, whether it's coming from the water to the land or reversing itself. There's always a breeze near the water. So that's why they put the windmills there. Not just because because it's just the water. There's a reason. The reason is there's always a breeze near the water. All right, your homework, and I know I gotta go put it over here. Page 28. So flip over the page, not the top part. Questions 18 through 22. So that's 5. You guys got a little less than 5 minutes right now. Read them and actually do them. I know you can just circle questions, but I want to make sure you guys get this concept. All right, so again, your homework's just the bottom of the page. Do not do the top. We got to do those notes later. Just the bottom.